Hi, this is János, it's Real World Audio, and I'm going to answer a comment on crossovers. And do you think having an external crossover encased in a Faraday cage would matter enough to warrant doing it? So basically, not just taking the crossover outside the speaker cabinet, but enclose it in a protective cage that protects it from electromagnetic interference. Is it worth to do that? And I would say it's worth enough to do it because you cut down the EMF, EMI from the crossover, so you will get increased clarity in the signal. However, by adding a Faraday cage, you also add capacitance to the crossover components. So depending on the application, depending on your neighborhood, if you live in a very busy town, in a high rise, you have a lot of polluters nearby you, like lots of cell phone users, Wi-Fi, all this stuff, then enclosing your crossover in a Faraday cage will be, I would say, 100% beneficial most of the time. And it will be probably a significant improvement in sound quality. However, if when you live in a rural area, you don't have like a million people around you, you don't have like tens of thousands of electric devices surrounding your room, in that case you don't need such drastic shielding, and then the negative of the shield will weigh more for you, and basically you will notice mostly that there might be a tiny increase in the level of clarity only when your system is of extremely high resolving level. If not, if you have an average level system, then in such a condition, adding a Faraday cage, you will probably notice nothing. Uh, However, if you have an extremely resolving system, then that Faraday cage will give you a tiny bit of clarity in the mid-range, maybe in the bass, but the air, the top high frequency, if your hearing is out to 20 kilohertz, you will notice a drastic decrease in the very top air that you can hear. So some manufacturers have a grounded copper layer in a speaker chassis, so surely it's beneficial, just it's expensive to do. Yes, so what you can do is you can shield the inside of the loudspeaker as well. So you can shield, you can put a Faraday cage around your crossover inside the loudspeaker. So you don't have to have the crossover outside. If it's inside, actually it matters even more when the crossover is inside the loudspeaker, because then you are shielding the not just the crossover network itself, but you are also shielding the drivers from the crossover, because in the crossover you have the capacitors, you have the inductors, and they are generating tremendous amount of EMI radiation. And when it's an internal crossover, it's close to the driver's magnet voice coil structure, so that EMI will be significantly interacting at and altering the low level, the fine details, the fine structure of the music. Of course, if you have a very low resolution system, you will barely notice it, because the level of these changes, or level of that shielding, is really going to matter, going to count for the fine detail level. And your system has to be able to differentiate those fine detail levels for you to hear it. So that's why in like really low category loudspeakers, there's no necessity for shielding, because your sources, your amplifiers, and your cabling you are using don't allow you to hear a big enough difference with shielding to make it cost effective. And yes, it is really expensive because you need copper for that, and that's a very I would say, a rather expensive material. And when you look at loudspeakers, they try to use as much copper, as much brass, as much cheaper metals instead of coppers as much as possible, and just use the cheapest, barest materials. And not because they want to cheat you, because they want to sell you a product at a price that you can afford, and it doesn't feel like pulling your teeth. And when it starts to feel like they're pulling your teeth, that's because of the costs involved with the production. And the copper Faraday cage does really big time increase the cost, because it's not just the cost of the metal, it's the cost of the shaping, of the molding of it to create that cage. You also need a process, you need to create that. It's not enough to get a sheet of copper, and you don't think about that the price of the Faraday cage is just the price of the grams of copper used in it. It's way more than that. The fabrication cost is even more than that of the metal usually. So then again, why in the world is a thick layer of copper needed? Is it a waste of copper, or does it have benefits over a mesh Faraday cage? Because it does not need to be solid copper to act as a Faraday cage. It can have holes in the copper, just basically a copper mesh, and based on the size of the holes, you can design it so that it shields from the appropriate frequency EMI waves, EMI radiation. And now, if just a thin mesh is enough to protect, why do they use thick copper instead, which is much more expensive than a thin mesh? And the reason for that, if you put it in a loudspeaker, if you put a thin mesh or just a thin sheet, then because of the air pressure changes in the cabinet, it's going to vibrate and resonate. And what is happening when you have a moving sheet of metal that's absorbing EMI radiation? So basically, it's transforming it into an active electrical current. So basically, now you are creating a secondary generator of EMF that's pulsing with the acoustic energy. So that's why you need a thick copper cage inside the loudspeaker to shield the crossover, because you don't want that mesh to become an extra radiator of these energies. So instead of them being protective from what's coming from the loudspeaker coil, those EMIs and the EMI field that's in your home, yeah, it will still do that, but it will, based on the acoustic signal, become a generator itself, and generate that energy, those pulses, into the crossover from every direction. So it's a really effective problem child over there. So that's why they have to use a solid copper block, so that it does not resonate with the acoustic energy present inside the cabinet. However, that's almost next to impossible to do, because any metal object will have resonant frequencies at which they will start to resonate, even if it's really thick and heavy. So if the company has a lot of brains, then what they do is that they have these the crossover encased in a thick layer of copper, and they add wood on top of this copper cage, so that the wood alters the resonant frequencies coming from the inside of the cabinet, inside of the chassis, and it breaks up those sharp and shrill metallic resonances that the encasing does. So if you have a loudspeaker like that's what you can do. You can just glue pieces of wood onto your copper cage, Faraday cage, and that will cut down a little metallic taste that they generate. But still, when you have this really thick copper shield, it also adds capacitance, and that cuts a little bit from the very top end air and energy. However, uh, is it really worthwhile to do it in a loudspeaker? I would say just by removing the crossover from inside the loudspeaker cabinet to become an outboard crossover, there's no need anymore for that heavy copper shielding, so you can tremendously drop the cost. And also, if you have just a very thin copper mesh, it adds much less capacitance compared to a very thick copper cage, and you can cut down that effect as well. So it's much more beneficial to have an outside crossover with a light Faraday cage compared to an inside crossover with a super massive Faraday cage, because it doesn't matter even if you make that Faraday cage very solid. Inside the chassis, inside the cabinet, there will be still enough mechanical resonances to just mechanically vibrate the crossover elements, and it will never be as good as having the crossover outside the loudspeaker cabinet. And just by taking the crossover from the loudspeaker cabinet, in most cases, you really don't need that Faraday cage anymore, because that cage, the prime function of it is to shield your voice coil and your loudspeaker, the driver itself, from the radiation of the crossover, because the crossover is a bigger evil than your voice coil. So by taking it further away from the voice coil, it's enough to decrease its effect to a degree that that a Faraday cage will be really minimal compared to that, and it will come to play sometimes big time when you live in an atrocious neighborhood that's a really bad EMI polluter. So I hope I have answered this comment, and also part of the comment, well, good to have voice coils shielded too, and shielding the voice coils is much easier, and it's done at the level of the driver manufacturer. There's a little bit of cost involved, but when they put that into production, the cost of that is absolutely negligible compared to putting Faraday cage around the crossover. So basically, the best practical approach is to have a shielded voice coil, I mean driver with a shielded voice coil, and crossover outside your cabinet, and a light mesh of copper Faraday cage only then you live next to a cell phone tower, or you have neighbors who use like there's like a 50 Wi-Fi networks around you when you try to look for Wi-Fi networks, and uh, maybe you live next to a shopping mall or something like that. So have an awesome day. Please like, subscribe. Bye bye.